Healthy homes start with healthy building envelopes. So today I'm going to teach you about how to achieve a healthy building envelope and what that means. This is the building shell, aka the building envelope, right? And we're addressing multiple factors here. We're addressing air, water, and thermal factors related to this building. The air is the primary factor that we need to concentrate on. It's going to be the most important. If we really seal all of our buildings off from the outside via this block and caulk method that I've come up with, then we are going to mitigate all air infiltration into the home from the outer shell of the envelope. And simultaneously, when we do that, we're also going to be preventing any water from getting inside the envelope. Because just think about it. If you block all the air, you're going to block all the water simultaneously. So it kills two birds literally with one stone. Now the thermal capacity of this building envelope. This particular sheathing is integrated with rigid foam on the inside of the sheathing. So this panel goes onto this wall and instantly creates a continuous thermal break around the entirety of this building envelope, including the roof. And we're the only company in North America that I'm aware of that is using this process to actually use the same insulated panels on the roof. And we are getting that continuous thermal break the moment we get our building envelope enclosed with these panels. So again, we've hit air with all of our tape. We've caulked at the base of our foundation to our sheathing, right? Then we've added a little bit of additional robust damp proofer, and we've added some waterproofing to the base of the brick ledge. And then we have addressed the entire, above the wall, right, where we get up to the juncture of the roof to wall interface, we've got that all sealed off really well. If we had any rafters sticking out, we would be caulking around all of those rafters. That's part of the blocking caulk method. And then guys, we've taken caulking and we've added it to any penetration that we have that's small, like all these little fastener holes. All of that has through the roof caulking, and that has addressed our air, water, and thermal on the outside of our building shell. This will successfully keep all sorts of water and humidity, allergens, you name it, from getting inside our house, right? If we had these little holes at the base of our wall to our foundation, then we could end up with potential rodent locations where rodents could get in. You can get things such as feces and dust associated with that infiltrates into your building as you get your home pressurized, whether it be positive or negative, and that can be really bad. So again, you want this guy sealed off as good as you possibly can. We are the best in the business. We do not use any sort of interior sealant method. There's something called aero barrier, which is an aerosolized spray caulking, and that happens from the inside out. Most builders achieve tight homes by putting a bunch of spray foam inside the wall cavities. Now just imagine if you are lacking in the air and water sealing on the outside, but the inside of your wall is really robust with that specific trait. What can happen is you can actually create pockets where water can infiltrate in but not get out, right? And that could create a moldy house situation. That is a big problem with many homes in North America. So if you're going to use spray foam, that does not mean that you get to be sloppy on all the exterior air and water sealing. So we make that our primary focus. Our blower door scores are the best in the entire city. And we do it at frame stage. Most people take that grade at the end of the project once they have the insulation in, typically it's spray foam for them, and once they have the drywall in, which is an additional air barrier. We're measuring ourselves beforehand when we have the opportunity to fix any issues, any problems, and we're achieving the lowest scores in the city. This one was 0.66 ACH 50, which is again about 10 times better than what code requires. So that's super, super, super tight. Anytime you're getting 1 air change per hour, below 1 air change per hour, you have been extremely successful in your air sealing. And that means simultaneously you're going to be extremely successful in your water sealing. And again, we have that continuous thermal break on the outside of our building, and that's going to mitigate any cold condensing surfaces from existing inside our home. So that means our home will not sweat on the inside. Now, being that we're not doing the spray foam, we're able to use all kinds of different insulation opportunities, right? We have lots of opportunities. We can go with a hemp, we can go with a rock wool. In this case, we were a little bit more value oriented, so we went with a blown in fiberglass. And that blown in fiberglass is going to be much more forgiving of some sort of water or anything getting in that wall. So let me take you inside and we'll go look at the fiberglass inside our wall. All right, so now we're inside the home. It sounds like an absolute dead space because this fiberglass is so sound deadening. And as you can see, this is the fiberglass. This is what it looks like if you somehow got a leak from the cable guy, let's say coming years after we've built the home and he messes with our air and water barrier and somehow he ends up successfully getting some water inside of our wall. Well, our seal is all exclusively from the outside. It's not on the inside. So the inside actually communicates with the HVAC to some minimal degree. We try to avoid caulking of baseboards to the floor, and part of that rationale is so that if any water could get in, it could also successfully get out. That would allow it to theoretically dry without causing a mold situation. Whereas if this was all spray foam and we got all this and we got water in there, we probably would never know that the leak existed and this wall would be totally molded. So that would be a horrible thing. On top of it, we're actually installing this blown-in fiberglass for roughly half the cost of the spray foam, and we're not dealing with any of the toxic off-gassing of the spray foam, which to me is a very nauseous, toxic experience, and both during the install, but also after. It off-gasses infinitely to some degree. And to me, because we have the opportunity to select one single product for this entire home to put on pretty much every single wall, I'm very thoughtful about what that product is, and I want to do that with a bunch of intention, and I want to make that as healthy of a product as I can. Now, to make sure that all of our windows are completely bulletproof, what we've done is we've taken our flashing tapes, in this case, and wrapped them around the entirety of the rough opening prior to putting this giant window in, and then we've shoved foam backer rod around the entirety of the window frame, and then we've back caulked everything. So literally, this is a total gasket. This window cannot leak to this rough opening, add this rough opening to the inside. So even if this frame fails or this glazing fail, all those things are possibilities. This cannot leak back to the inside because of the perimeter gasket that we experience, and everything would go down and out as it should in successful waterproofing mitigation measures. So guys, again, a healthy home starts with a healthy building envelope, and that's why we build the best in the business. And I'm happy to share all of my bag of tricks with y'all because I would love nothing more than all the homes in North America and the world to be healthier and happy places. Hope that helps. Adios, amigos.